Hey there, everyone. Welcome back to another session where we explore the fascinating world of energy stores and transfers. In today's lesson, we'll dig deep into how energy can be stored, how it moves from place to place, and what happens when objects speed up, slow down, heat up, or give off sound. I'll be asking lots of questions to get those gears turning in your mind, so get ready to pause, ponder, and participate. First off, let's remind ourselves, energy doesn't just vanish. It's always either being stored or transferred in some way. Here are some main stores we talk about in GCSE syllabus. Chemical energy store, found in fuels, food, or batteries. Released by chemical reactions. Kinetic energy store, associated with anything that's moving. Gravitational potential energy store, linked to an object's position above the ground. The higher it is, the more potential it has. Elastic potential energy store, think springs, rubber bands, or anything stretchy and squashy. Thermal energy store, depends on the temperature of a substance. Hotter things have more thermal energy. Energy can be transferred in several ways. We usually see it transferred by forces, a push or a pull that moves an object. Electric currents, through wires. Heating, conduction, convection, radiation. Waves, light waves, sound waves, etc. Can you think of a time when you transferred energy by applying a force? Maybe you threw a frisbee or kicked a ball. What energy store did you transfer from, and where did the energy go? Pause the video and try to answer. Okay, let's investigate step by step. When you apply a force to an object, like kicking a football or throwing a frisbee, you're transferring energy from your muscular, chemical, energy store into the object's kinetic energy store. In the case of kicking a ball, your muscles, which draw on chemical energy, do work on the ball by pushing it forward. That work converts chemical energy into the ball's kinetic energy, giving it speed and movement. Some energy may also go into heat, friction in your foot and ball, and perhaps sound, the thump noise. Here is another question. What do you think of electrical energy? Picture a phone charger. Where does the energy start, and where does it end up? Pause the video and try to answer. For electrical energy and a phone charger, the energy path typically goes as following. First, the charger is plugged into a main supply, electrical energy source. Second, the charger converts that mains electrical energy into lower voltage electrical energy suitable for your phone. Third, the phone stores that energy in its chemical battery, the battery's chemical energy store increases. Fourth, when you unplug and use your phone, the battery's chemical energy converts back into other forms, electrical, thermal, kinetic in the phone circuits, or even light and sound when you use apps and make calls. Now let's see an example of a toy car zooming across the floor. Imagine you have a toy car that you wind up before letting it go. Here's what happens at different stages. During winding the car, you're putting in effort, mechanical work, storing energy in the car's elastic potential store. The spring inside is tightened. When released, the stored elastic potential energy turns into kinetic energy as the car zooms forward. Eventually, the car slows down because friction transfers some of that kinetic energy into thermal energy. The wheels and floor get a little warmer, and a bit to sound waves, the whirring, rolling noise. Think about it, where does the energy end up if the car totally stops? Are there any forms of energy we might overlook, such as the slight warming of the floor? Imagine you throw a rubber duck high into the air. As it rises, kinetic energy decreases while gravitational potential energy increases as it's getting higher. At its highest point, it momentarily stops, kinetic energy is almost zero, and gravitational potential is at a maximum. As it falls back down, the reverse happens, gravitational potential energy decreases, and kinetic energy ramps up again. When it finally hits the ground, some of that kinetic energy transfers into thermal energy. The duck and floor may warm up a tiny bit, and sound, a thump noise. Notice how we never say the energy is lost. It changes form, or it moves into the surroundings, but it always goes somewhere. Let's consider an electric hand warmer you switch on. It has chemical or electrical energy store, the battery or power outlet is the source. Then energy transfer through wires, electricity flows from the battery to the heating element. And then there is a thermal energy store, the heating element warms up, transferring energy to your hands and the air around. If you've ever wondered why batteries eventually run out, it's because their chemical store has been converted and transferred elsewhere. Once that store is used up, you need a fresh battery or to recharge it. Now it's your turn to apply these ideas to brand new scenarios. Let's see how well you understand. A roller coaster car is slowly pulled to the top of a big hill. Then it rushes down at increasing speed and finally levels off. Describe the changes in gravitational potential and kinetic energy throughout the ride. Where else might energy be transferred? You have a small toy that runs on solar energy. On a sunny day, you put it outside, and its little fan starts spinning. Which energy store does the sun supply initially, and how is it transferred to the toy's spinning fan? You place bread into your toaster and switch it on. After a minute, your toast pops out. Trace the path of energy from the power socket, through the toaster, and into your breakfast. Mention at least 2 types of energy stores. You drop a basketball from waist height, and it bounces back up, but not as high as before. Explain why it doesn't bounce back to the original height in terms of energy transfer and the stores involved. Feel free to get creative in your explanations. The more detail, the better. Energy can be stored in various ways: chemical, gravitational, kinetic, elastic, thermal. Energy doesn't vanish, it is transferred via forces, electric currents, waves, or heating. Whenever you see something moving, heating up, lighting up, or making sound, there's an energy transfer happening. Identifying the before and after energy stores helps you piece together what's really going on. Alright, folks. That's our deep dive into changes in energy stores. If you found this lesson helpful, please remember to like, subscribe, and ring that notification bell so you don't miss our next science adventure, including the solutions video that's coming up. Now it's your turn. Pick one of the practice questions above, or come up with your own real-life example. Give it your best shot and write your answers in the comments section below. Once you've tried them out, join me in the follow-up video where we'll walk through each solution step by step. Let's see how creatively and accurately you can apply these concepts. Until next time, stay curious, keep experimenting, and never stop asking questions.